I'm Ashley, for those of you who don't know me, and I'm really excited to introduce y'all today Jasmine Locke Rodriguez. She's a PhD from FIU and is currently doing a postdoc there. Jasmine and I first met 2 years ago at the Biscayne Bay Aquatic Health Summit. We were getting coffee and she had the mug from an international meeting that we had just been to in Madison a few weeks before. I was like, oh, I was at that meeting. That initial interaction led to this longer conversation where we both realized that we have a shared interest in restoring water quality, but restoring water quality through different means. I think about restoring water quality a lot with using shellfish and seaweed. And she thinks about it with coastal wetlands. From that initial discussion, we continued to talk. We even wrote a postdoc fellowship proposal together from the Smith Fellows Program, which is funded by the Society of Conservation Biology. Jasmine unfortunately did not get that, although she did make it to the finalist stage, which was pretty great since there were over 100 applicants and they only award the fellowship to 5 people. And I think in the end, it kind of maybe worked out for you. We'll see, because she's been able to take on a lot of new opportunities, including starting her own small business. So when Monique reached out for people to come and be seminar speakers, I automatically thought of Jasmine because of what I think she can offer to the graduate students, as these are things you can do with a PhD, or look where this PhD took me that's not an academic job. And also because I think she thinks a lot about the same issues that we all think about here at TREC. And I wanted to make sure she was aware of the resources that we have here while she starts diving into some new adventures. So I'm really excited to hear more about what she's been thinking about more recently, and then some of the work she has been doing previously on floating wetlands. So with that, I'll hand it over to you.
Thank you so much, Dr. Smith. It's been such a pleasure to learn from you and to learn from TREC. Have a wonderful tour and see a lot of the great work that's done here that I've enjoyed following over the years myself as well. So as she mentioned, I am a recent graduate of both the FIU Agroecology program as well as the FIU CREST program, which is the Center for Aquatic Chemistry. And I was just telling the lab earlier, I'm in one meeting, I feel like the weird water girl in agriculture, and when I'm in the water meeting, I feel like the weird agriculture girl in the water meeting. So I'm excited to share with you guys some of the vision that I see of how both agriculture and really water remediation can be a little bit more integrated. Some strategies toward applying green infrastructure on both the farm and off the farm, and a little more about these floating wetlands that I've been working at. So thank you for having me here today. So a quick overview, I'm going to talk about the problem of nutrient pollution and eutrophication, especially in coastal areas like South Florida and Florida overall. I'm going to briefly introduce the idea of regenerative agriculture, which many of you folks may be familiar with. Discuss best management practices that can be applied on the farm and how to incentivize applying, also known as BMPs, in slightly creative applications on the farm, and then move a little beyond the farm as well and think about how cultivating different types of valuable crops can also still help with water remediation efforts across the region. And we'll wrap up from there. So nutrient runoff is an issue that occurs across the world and is especially an issue in Florida, where I have here that in Zone 10, which is South Florida, but really across most of Florida, we have 2 major seasons, unlike the rest of the country, right? We have a wet season and a dry season. And the wet season goes from May to October, and this is when we have increased amounts of storms and really an increased amount of precipitation. And when we have all this rainfall, we start to bring whatever's on our lands into slowly water. And a lot of times this includes fertilizers that's either on our farms or on our lawns, as well as organic debris. And you can think of other types of urban contributions, such as from septic tanks as well. With increasing storm levels from climate change, this is happening more and more. And what happens when these nutrients end up into our water? So essentially, nutrients have a funny rap, right? They sound like a good thing, but essentially too much of anything is going to throw off the balance of the ecosystem. And what happens is, instead of feeding the plants that they may have been originally applied for on a farm or on a lawn, now you're feeding something else, algae. And too much algae can turn into an algae bloom, which blocks light from entering the water table, which can inhibit the growth of seagrasses and other types of photosynthetic organisms and cause a ripple effect. Also, when algae dies back, the decomposition of this algae starts to reduce oxygen in the water and essentially recreate hypoxic zones and create dead zones. Unfortunately, in 2020, we had one of the biggest fish kills in the region where, and this happens during the rainy season, we had thousands of fish wash ashore around the Biscayne Bay. And similarly, this type of pollution can impact, as mentioned, seagrasses, which through this process are being essentially suffocated through eutrophication as well. So agriculture is often cited as one of the leading contributors of nutrient runoff really across the globe. And looking a little closer at the types of nutrients that are coming out of canals in Miami, you can actually see in the southern Biscayne Bay when we're looking at some of the major canals like the Black Creek Canal and Murray Canal that are running through the Redlands, we have high levels of total nitrogen coming and unloading into Biscayne and contributing high amounts at this time. So it's one indicator that farms in the area can be a leading cause of eutrophication, at least for the southern Biscayne Bay. So what can we do about this, and what do farms do here and across the region? Agencies like the Florida Department of Agriculture and even the Department of Environmental Protection help advocate for applying best management practices, otherwise known as BMPs. These are essentially strategies that help improve water quality using practical measures to reduce fertilizers and animal waste and other pollutants from entering the water. 3 major ways to do this are: 1, essentially managing the amount of nutrients you're putting on your property; 2, managing the amount of irrigation you're applying to your property; and 3, adding layers of water resource protection. And you know, this image kind of gives you an idea. So that can include different types of vegetation, buffers, wetlands, and all these are meant to help reduce nutrients from running off of a property. In watersheds where water quality is a really high importance issue, some BMPs are mandated and regulated on different farms, and so it becomes a part of the management plan when they're on their farm. But I wanted to point out that while there are ecosystem benefits and obviously reduction of water of this runoff, there's not always a direct financial incentive to place these on their property, and can be a bit of a burden to farmers sometimes. And so that's where I kind of wanted to integrate this idea of incentivizing BMPs with kind of the new hot topic, which is not that new, of regenerative agriculture. And regenerative agriculture means that it leans on these holistic principles that are meant to restore soil, ecosystem health, address inequity, and leave essentially our land and water better than we arrived, and leaving it better for future generations. Typically, this often looks like improving our soil health, which I'm sure we talk a lot about here, adding organic matter to our fields, which helps hold on to water and help pull nutrients into our soil profile, as well as pulling water down into our water table and our groundwater. This also is discussing, sequestering carbon so that we can pull it out of the atmosphere and store it into our soils as a bank, really, for our crops and for our environments. When it comes to directly addressing nutrient runoff, I think that we can push the narrative a little bit more for regenerative agriculture, because essentially when I hear regenerative agriculture, I hear, let's not only grow something for our communities, but let's improve the ecosystem in the process. And so unfortunately, in Florida and South Florida, we have really rocky soils, really sandy soils. And so even if, we layer tons and tons of practices focused on the soil, there's often inevitable runoff that's going to happen. And so I'm here to kind of advocate for the idea of bringing these regenerative practices in a little more alignment with water restoration as well. So how can we do that? And how can we make these practices a little more financially sustainable? Essentially, we know that plants naturally take up nutrients. And so we can leverage the power of plants at different points in the landscape to help accumulate those nutrients before they run off the farm, or even after they've run off the farm. And taking it even a step further, we can grow something that we can harvest and process. So we might be familiar with what are riparian buffers. This is essentially growing layers of trees and products along the edges of our farm. And this is a very common BMP recommended to help with essentially catching nutrients, water, and sediments before leaving the farm entirely. They can add a lot of benefits to our ecosystems, like what I just mentioned, as well as carbon sequestration, which is something we talk about often, and helping with mitigate from flooding risks as well. And what I want to introduce to this idea and kind of point out as a point of discussion that some folks have brought up is that if we can plant things along these buffers that also can provide added value to our farmers. Things that we don't need to fertilize directly and want to avoid fertilizing directly, but can instead uptake these nutrients that might be leaving the farm. So one of the things that are really important for successful buffers is to have really deep roots, right? That help create a really strong soil structure. So essentially that means we don't want to be planting anything that we're going to completely remove every year. But if we're planting things that are perennials, that have harvestable products in the process, then we can create a little more incentive potentially for farmers to apply these and even a wider range. So, for example, this cross section here shows us that the first 15 feet next to, I'd say the edge of your property or even next to a water body, you want to stick to planting natives and more wetland related plants. But beyond that 15 feet, you can start to plant things such as trees for fruits and for nuts. I mean, really thinking agroforestry, things that can grow there for many years and we can harvest from at the same time. This can also include other types of kind of mid-size plants if we're going even further into zone 2 and zone 3, further away from the water's edge, such as elderberries is a really incredible native plant that has really deep root systems that are also a really valuable product that you can harvest from regularly and doesn't need to be fertilized often. So essentially trying to grow plants and products that can help with on the edges of our property or on the edges of water that also provide added value to our farmers. And so this is a little bit out of my, expertise, and but there are ways to grow different types of product for timber as well that, if harvested sustainably, so for example, there's practices called shelter wood cutting, where you only cut a few trees at a time, and let a lot of other ones stay in at the same time, keep the roots in soil. Then you can still help stabilize the soil, help collect that excess runoff, and still potentially provide a product in the process. Of course, you need to be careful about the types of plants, trees that you would plant. It's obviously better to be growing natives, but there's also plants like eucalyptus and even some bamboo that grow quickly, that can be harvested fairly frequently, but still keeping the roots in the soil to help with collecting that runoff. So food for thought. Moving from the edge of the farm and a little more directly into the water, I am here to introduce the idea of floating wetlands. So keeping with the idea of growing something, well, first let me introduce what floating wetlands are. So essentially, floating wetlands is bringing the concept of wetlands to deeper water. And in Florida, where we have, our urban communities and we need to help protect our communities from excess flooding, we often need stormwater ponds to help collect all that water. But a typical wetland needs shallow water in order to prevent these plants from being submerged or drowning. And that means, well, in the face of development, we're losing a lot of our wetlands in the process. And so we can't often have wetlands integrated into an urban community or even on a farm when you're often, facing these trade-offs of how much land can you use for production versus how much you might want to keep just for the sake of cleaning your water and conservation. So floating wetlands kind of help bridge the gap where we're able to use these floating platforms to grow plants into these platforms, allow the roots to grow in the water and naturally uptake these dissolved nutrients that have been washed away and absorb that into the biomass of the floating wetland. What is important for these systems is that we harvest the biomass frequently, because if we don't, the plants can start to die back and fall into the water, and essentially return these nutrients right back to the water. And also, the more that we stimulate the growth of these plants, this kind of goes the same for the perennials that we were talking about on the buffer, the more the plant creates more biomass, and therefore also increases the nutrient removing efficiency. So if they're growing and they're in an active state of growth, they're more likely to uptake more nutrients. So it's a way to kind of promote that phytoremediation process, which is using plants to remediate water and soil. However, harvesting from a floating wetland can be labor intensive, just like harvesting anything could. So why not make use of that harvest and grow something that we can sell? So my dissertation work focused on growing flowers on these floating wetlands to incentivize this harvesting regularly and be able to clean the water at the same time. It turns out that the cut flower industry for the US is actually housed in Miami. And that's because nearly 80% or more of flowers are coming in through the Nashville airport here and being made into bouquets and redistributed around the country right here. So, and this Miami Herald article shows us that during COVID, when we weren't able to import things, that made a huge impact on the cut flower industry. So I thought, hey, let's grow some flowers on these mats. And not only can we have a valuable product, but we can even bring an aesthetic to this remediation process. This concept was also inspired by floating farms as a concept that's existed throughout really centuries and through cultures throughout history. One example are chinampas of the Aztecs in Mexico, who did grow a lot of their food on floating mats. And so I thought that this could be a really neat integration that could potentially be applied either on a farm directly and essentially incentivize a farmer to have a reason to clean their water because now they have an added stream of income. So these are a couple of the flowers that I was able to grow on the floating wetlands in my dissertation. These are some of the nutrient removal capacities I was able to quantify. That picture in the back is a rendering of a vision that I can see growing floating flowers on a farm or on a larger lake or stormwater pond. The amount of nitrogen and phosphorus that these species were able to remove on a meter squared basis, I estimated how much that could look like over a year, because at least in South Florida, we have a mostly year-long growing season, especially with flowers. And so this is something that we can do most of the year long, even if we're replacing the flowers every couple months as they cycle through. So something I wanted to do and quantify as a part of my research was to calculate what's the cost, the benefit cost analysis if a farmer wanted to apply this on their stormwater ponds. One thing to note about these floating wetlands is that we're not here to cover the entire pond. We would only cover a portion of it, somewhere between 10 to 25% of the surface area is probably ideal. So on a quarter-acre pond, which you might find on a farm, we would cover about 200 meters squared of a floating wetland on the pond. And comparing growing flowers on these platforms directly with what is traditionally grown on these platforms, which is typical wetland plants, I was able to quantify that not only can we essentially mitigate the costs of the system within the first couple seasons, but we can eventually make profit from growing them as well, while remediating the water in the process. And although the flowers might not entirely measure up to a typical wetland plant, they are pretty similar, and we can potentially integrate some wetland plants amongst flowers on a platform like this. I don't think I mentioned exactly, but so floating wetlands is a type of green infrastructure, which is essentially using nature as inspiration to help address nutrient runoff and other ecosystem issues. And typically, this is kind of like a growing type of application that a few different products exist out in the world and on the market. And a lot of people usually are using just typical wetland plants on these platforms. And that's where we differentiate ourselves a little bit. And as Dr. Smith mentioned, as a part and kind of inspired by this research, I have started a startup. It's called Phytoflora, thinking about phytoremediation and flowers combined, and bringing the power of plants to different areas to help clean that water. And so going even beyond the farm, we can apply these floating wetlands to other types of water bodies across an urban community, across an urban landscape. That could look like a canal, that could look like a pond. And flowers, we found out, prefer the fresh water. So in areas that are more brackish, we could also consider growing things like mangrove saplings or other type of more brackish growing natives that can be grown for the first 6 months to a year of their life. And then they can be uppotted and sold to be planted on restoration projects, living shorelines, etc. So essentially, kind of what I'm hoping to do with this venture is to create a new type of farmer where we're, interested in cultivating products, but maybe on a non-traditional setting. I wanted to show you a little bit of insight as on a model that I did do on the Little River Canal, which is one of the leading contributors to nutrient pollution in the North Biscayne Bay. I proposed to cover the canal 13% of the surface area with these floating wetlands, and that's kind of a close-up here of what that would look like. So kind of on the edge, kind of allowing boats to still be able to pass through. And I only proposed it for the freshwater area because I was quantifying the flowers' productivity and with the data that I had on how much nitrogen and phosphorus they were able to remove. So then I also accounted for the fact that at least on a canal, when the water is passing by, we're not going to be able to capture all the nutrients because they have to pass the root zone of the plants. And so I was able to quantify about the amount of the percentage of the water volume they would have access to and exposure to, and compare that to the annual predictions or annual loads that have been quantified that are happening between both the dry and wet season, because those can change a bit from season to season. And so I was able to predict that these floating wetlands would be able to remove at least 8% of both dissolved phosphates and nitrites. And if we are able to adjust the flow or a little bit, or help direct some of the flow of the water a little more intentionally towards the floating wetlands in certain areas, then we have the capacity to remove even more, up to 26% of the phosphates and 14% of the nitrates. Also, this is not accounting for the fact phosphorus, especially when the water slows down and it's trapped in sediments, it can settle to the bottom of the canals or the lakes, whichever the scenario is. And so these are kind of, humble predictions, because there's a lot of understanding that we'd probably be able to capture and at least be able to prevent those nutrients from entering downstream into the Biscayne Bay, for example, and potentially be able to do some prescribed dredging every couple of years, that we are capturing these nutrients. So that's floating wetlands, and I just wanted to add a couple other ideas when thinking about regenerative farming or different types of cultivation that is, continuing in the same line of thinking. One project that I'll be working on as a postdoc, building off of this project that's been happening at the agroecology program, is collecting algae from lakes, drying it and repurposing it as a biofertilizer. This, by removing and harvesting the algae before it dies back in a system like this, we can help prevent eutrophication from happening as the blooms are occurring. And a trial that took place comparing these biofertilizers to, so we're calling it biofertilizer, compared to a typical synthetic fertilizer, shows that they were fairly comparable as far as how much growth you could expect from either scenario. Some benefits of these biofertilizers is that they have a high carbon to nitrogen ratio, which means that they will decompose quickly. And another great benefit is that they have high levels of iron, which is something that's often depleted in South Florida soils. So they can be a great supplement for iron. When comparing how much cost saving, if you were to replace, synthetic with recovered biofertilizer like this, the study was able to show that there was a significant amount of savings as well. And because I have to shout out our restorative aquaculture practices, just looking, if we're thinking, starting from the farm and moving further away and then into the oceans, of course, we have other types of cultivation, such as seaweed farming that we might know about, as well as oyster farming that naturally helps uptake nitrogen that's already ended up in our oceans. And this is a figure from the Nature Conservancy that shows that more than half a ton of nitrogen can be removed. So I guess in this case, we're combining both oyster farming and seaweed farming as well. And essentially, we're able to remove more nutrients than we don't have to add anything to these systems. So it's an incredible way to think about regenerating our ecosystem, but in water. And typically this is called restorative aquaculture. And there's a whole world of that can be explored. And I guess with each of these concepts in mind, I just want to inspire, a new type of farmer where we're able to bring, ecological benefits to what we're doing and improving the health of our ecosystems while still creating a financial opportunity. I think one of the issues, we got in the Herald last week, so that's a little snippet of the article. And I think, coming out of my undergraduate degree and being a conservation person, I found it so difficult to work in an area that, can sustain livelihoods. So many of these projects are completely dependent on philanthropic efforts, on conservation dollars. And I just felt like, there's got to be a way that we can do more that also creates green jobs and supports livelihoods and communities in the process. And so that's, I guess I wanted to start there. Like I grew up in Miami and I fell in love with the water. And when I found out that nutrient pollution was causing such damage, actually out in the Gulf, I learned about first the dead zones. I was like, there's got to be a way to kind of bridge this gap of farmers and conservation a little more, because at the end of the day, the people throughout history who've worked the most with our land are our cultivators and our farmers. So I'm just wanting to bring a little more of these concepts and ideas that can help bridge the gap for folks who want to integrate more of these conservation practices, while also being able to sustain their livelihoods in the process. These are some of the studies that I spoke about. And I want to thank you for your time. And I just want to do a quick shout out for anyone who might be online or in the audience who knows a farm or has a farm that has water on their property that might be interested in exploring some of these strategies a little more. I'd love to chat, and including off the farm as well about strategic partnerships in that way. So please feel free to contact me, and my email and my website is there. Thank you.